Hello, welcome to my presentation. My name is Asam Zimsonda Mwamba and I'm going to be explaining my works in sound sampling and synthesis. Question 1 reads, use SEQ3 in VCV Rack to come up with a musical loop. So the musical loop that I came up with comprises of 3 sounds, a bass synth sound, a kick, and a hi-hat. So this is how it sounds. So these are the modules that I used in this musical loop that I came up with. The first was clocked, then the SEQ3, VCO, VCF, VCA, a DSR envelope, mixer, scope, audio. I used trummer, 2 trummers, VCA, BPM delay, millisecond calculator, and then delay, also reverb. So the first module that I used was clocked, which was basically being used to send timing information or BPM to the sequencer. And then I used the ratio of 4 just to get that bit to be equal to a quarter note per bit, just to get that pulse on time. Yeah, so I had to route the clock 1 output into the input on the SEQ3. Then I also used it to get the clock output from the clocked into the BPM delay calculator, just to keep my delay and reverb on time. So the first thing I'm going to demonstrate on how to patch and create the sound or the bass. So start with the bass sound that I came up with. So on the SEQ3 here, it basically has 3 columns which you can use for control voltage. So it has 3 columns comprises of rows which has up to 8 steps. So for the bass sound that I came up with, the bass loop, to route CV3 output, which is these steps here, up to 8. I had to route it into the VCO, which is basically a module that is being used to generate a wave sound. So here on the VCO, the voltage controlled oscillator, I'm generating a sine tone wave with a fundamental frequency of 65.407. I had to divide that to get to that octave. So basically here, I routed the output CV3 from the SEQ3 onto the voltage octave pitch input on the VCO. Then I had to route sine tone output into the VCF. Here, VCF input, which is basically a voltage controlled filter. Then I had to set a cutoff frequency of 400 Hz just to get more of those low frequencies at a low pass filter. Then I had to get the output of the VCF and route it into the input of the voltage controlled amplifier, which is basically controlling my amplitude there. And then I had to route the output of the envelope into the input on the VCA, and then I had to route the output of the VCA into the mixer. This was basically used to balance the 3 sounds that I used to come up with this musical loop. So after routing it to channel 1, which is for the bass sound, to route the output of the mixer into the scope, just for visual representation of the sounds that is being generated, and then I had to route it to channel 1 and 2, and then I had to get the output of channel 1 and output 2 and routed it to the audio output device on left and right channel so that we can hear it through our monitors. So basically here I had to, on the envelope, I had to apply a fast attack, and had to apply a decay of about 105.68 milliseconds with a high percentage of about 82.4 sustain with a release set at 100 milliseconds. So basically, the other thing is the get information is being sent from the sequencer here into the get input, which is basically sending the get information to the envelope. This is the bass sound that I came up with. So I had to set a fast attack just to get that click sound of a bass. So basically here on the sequencer, the bass loop is using this row. So here I'd set a pattern. The only knob that I adjusted was this knob here. I had to set it to negative 0.2 voltage just to get or just to send that low voltage signal to the oscillator here, because the higher the voltage, the higher the pitch sound that is being produced, and then the lower the voltage, the lower the pitch. So I can try that by increasing the voltage here, so you can hear the pitch has changed due to that the voltage information is high. So let's take it back to negative 0.2. Yeah, so that's how I came up with that. And then the other thing is this, the trigger buttons here. These are basically switches. So here this switch applies to these knobs that are here, and then this switch applies to all these knobs that are here. So it affects all these knobs in this column. Then this button here also affects all these knobs that are in this column. So in order for me to create this pattern, I had to turn off some of these trigger buttons here. So for instance, if I turn off these two, the gate isn't being triggered on the envelope there, because there are no voltages being sent or no pitch information that is being sent to the gate there. So that's how I came up with this pattern of a bass. Yeah, so after creating the bass loop, the other thing I created was kick sound. So I used this module, which is Truma drum synthesizer. So this module basically generates percussive sounds or drums such as kicks, snares, and you can also use it to create toms. Yeah, so in this case, to route the output of controlled voltage 1, which applies to this row here, I had to patch the output of that into the gate input on the Truma here. So if I run this patch, we are not getting any sound. We can't hear anything. This is due to that there is a certain voltage that has to be reached in order for this gate to be triggered. So I'll move according how I want the kick to be playing, at what pattern for it to be playing. So I'll start shifting this knob up. So immediately after reaching 2 volts, we can hear the sound of the kick. The gate is being triggered. So in order for the gate on the Truma to be triggered, you need a certain voltage for it to be triggered. So here you can see a voltage of 2 volts is able to trigger the gate there. So here this doesn't necessarily affect the pitch. It's only sending the control voltage information to the gate there. So no matter how high the voltage will be, the kick will still just sound the same. So I'll set this at 2 just to make sure that it's triggering the gate, and then I also do this. Yeah, so now we have a pattern that is in a loop form. Yeah, so now did I come up with this kick sound? So Truma has two sections. There's an oscillator part and a noisy part. So in this oscillator part is what I use the most to create the kick sound. So here we have knobs like tune, which basically gives you the base frequency or fundamental frequency. That's where you set your frequency from. And then the bend basically affects the pitch, and then drive basically adds more energy to the sound. And then the other thing is that it has an envelope part where I can set the envelope or the sound that I want to create. So here I just added the fast attack, and then I added chord of about 0.2, and then decay or set at 0.451. And then the other thing, this is basically volume, the level, the sound that you want to make. And then on this other part where the noise adds texture to a sound. So for me to create this type of kick, I did not add any noise. So the routing of this, so it was from the CV output 1, it goes into the gate there, receiving the gate control voltage information. And then from there, I had to route the envelope to the VCA, and then I also had to route the output or this oscillator into the envelope as well, and the input, their channel input. And then I had to route the output or this VCA into the mixer. Thereafter, it was routed through the output of the mixer, the scope, and it goes to the audio. So basically here, I just had to make this type of a kick. So here, if I tune this pitch, I take it up, you hear the sound will change. Yeah. So I needed much of a thump and some low end, so I had to set the pitch at negative 0.00. The other sound that I created is a hi-hat sound. So I had to patch the CV to output from the SEQ3, which is this row here, into the gate input on the Truma drum synthesizer. So basically here, I wasn't using the oscillator part, I was only using the noise part, because the oscillator part I had to set the level at 0. Is due to that this will give me harmonic a harmonic sound, which is basically having a definite fundamental frequency. And yet the sound that I was trying to create, a hi-hat sound, is comprised of non-harmonic frequencies. So basically here I had to use the noise part only, which at least will help me to create that sound, because it's made up of all frequencies. Yeah. So basically here I had to tune I had to tune the sound here to about 0.6, and then I had to, the envelope, I had to set a very fast attack envelope, because hi-hats are known for that. Percussive instruments are known to have a very fast attack. And then I had to set the order at 0 as well, and then the decay was set at 0.3. Yeah, and then the level, I had to set the level at 0.6, and then the source was just at 0. Yeah, so basically here the routing was from the output, it goes into the VCA, and then the envelope output as well, it goes into the VCA input there. And then I had to get the output now. So I had to get the output from the VCA, and I had to route it into the delay, so that the hi-hat might just have that delay feel. And then I had to put some reverb just to create a room effect. Yeah, and just to create that space of the sound. Yeah, so this is how the sound is sounding without the reverb. So let me route this direct to the mixer. Just from the VCA into the mixer, we just hear how the hi-hat sounds. So that's the sound of the hi-hat. Yeah, so I had to set the attack very fast at 0, and then I had to set the hold at 0 as well. Then I had to set the decay at 0.3. Yeah, so without the reverb and delay, these are the hi-hat sounds. So I wanted just to add these effects just to add some space and some character to this sound. What I did is to route this output and put it into the delay, left, right. So I had to route the VC output into the delay, and then I had to route the output of the delay into the reverb, left and right. And then after that, I had to send this onto the mixer there. Yeah, so after routing the output of the delay into the reverb, I had to route the output of the reverb onto the mixer. I had to get both lines, left and right, and route it onto the same input channel. So here, the other thing I used is this delay, BPM delay stroke millisecond calculator. So basically, this puts the delay and reverb into the BPM that I've set here. It puts it into time. So the delay and the reverb is in time with the musical loop that's playing here. So let's just hear the sound after I did that, after I applied delay and reverb. So basically, using this calculator, I can decide on what type of delay note that I want, either a quarter note triplet delay or a whole note delay. So if we remove this calculator, this is how it's sounding. It's not into time, but immediately we put this back, it is into time. And then I can change it depending on what type of a note that I want. If I want, I can put it on a 4 note. That's how it's sounding. If I want, I can put it here on a half note, maybe a quarter note. So it also gives you that sound of a hi-hat. So I just to put it at half note here, minimum. Yeah, so this is basically the sounds that I created using these modules, and I had to use a SEQ3 as a step sequencer, which is basically repeating this whole melody that of musical loop that I've created. Yeah, so basically this is the sound that I came up with using these modules and using SEQ3 to create this musical loop.